Okay, okay. So, come over here. We're gonna go ahead and introduce ourselves to empirical rule. It's one of the range rule of thumbs that most of us call range rule of thumb, and it's very commonly used for quick estimations or estimations of how many percentage of values fall within 1 standard deviation, 2 standard deviations, or 3 standard deviations of the mean. But we're gonna find out for empirical rule only works for when we have the idea of normally distributed measurements. So if it's not approximately normal, we can't use empirical rule because we're going against the mentality of it being symmetric jumps. That's where the mean and standard become important, and that's why mean is very important and standard is very important to use when you have normal distribution. If not, we use something else that we're going to learn to be called the IQR and also the median. So in order when these are appropriate to use and when not appropriate to use. But anyways, so empirical rule. So we're saying here empirical rule. So we're saying here is for distributions of measurements that are approximately bell-shaped, okay, normal. Okay. We can approximate the percentage of the measurements that fall between a whole standard deviation from the mean. When we're doing for empirical, it doesn't do every standard deviation, it does whole standard deviations. We're saying, okay, within this amount, what is it? So you're gonna find out it's very limited to only specific types of measurements. But later on, when we get to normal distribution curve, you're gonna find out, hey, it's not limited. I can do anything I want. But the empirical rule is a very unique one. Anyways, the legion we're seeing here is whenever we see the x, we're talking about those are the measures, the values within the numerical variable. Okay. And when you see the z's, those are the corresponding standardized values, or also referred to as z-scores, that correspond to each of the measures in x. So, what we're saying here is, if I'm 1 standard deviation from the mean, I'm at z-score 1, to the right of the mean, sorry. If I'm 2 standard deviations to the right of the mean, I'm at z-score 2. If I'm 3 standard deviations to the right of the mean, I'm at z-score 3. And if I'm right at the mean, my z-score is 0, because I don't have any standard deviations within the mean. So what happens when you go to the left? Left, -1 z-score. Left 2 to the left 2 standard deviations, z-score -2. Left 3 standard deviations, z-score -3. That's what converts to z-scores and x come hand in hand. And they can be used interchangeably, depending on teacher and how you want to attempt problems. For the most part, most of the problems I'm doing here, I'm typically be using the x's, but I'll be using z-scores to help give me to these guys pretty quickly. And also, how do we actually use this idea? So once you want to do a empirical rule, remember these rules, because sometimes you might be asking, okay, what's the range of values that holds the middle 60%, the middle 90%, or the middle 95%, or the middle 99%, and you can find these guys out. And then also remember the curve and the percentage within here. But sometimes they won't be standard; they might have regions that you have to look out for and figure out. But anyways, let's go ahead and get to the fun and enjoyment of this process. So here's the key idea, and I forget to always change it. So you might want to do this on you guys' slides too, because I currently always forget to fix this part. And our saying here is, if I want to convert from x measures to z standardized values, z-scores, I should understand that if it's a sample, it's going to be x minus, it's always x minus the mean divided, or the measurement minus the mean divided by the z-score, or the standard deviation, and that gives you z-score. If it's a sample, you're using x bar and s. If it's a population, you're using mu and lowercase sigma. And I guess I'll note it here. So these guys here, before the ors, these are your samples, and these are your populations. And beyond this, if you have the standardized value, and you know the standardized values like the standard jumps, or the z-scores themselves, and you want to find the measure that corresponds with it, how do we find that? Well, the measure, the x that corresponds to the given z-score we have, is found by getting the mean and adding z times the standard deviation to it. This z-score times standard deviation. Because look, we already did here is we just solved for x using this expression, and we'll end up with the same answer. Just that we're not showing it, but you could work the math out and you can see it happens only 2 steps, and you get this guy to do what they said. But anyways, that's what's happening here, and we'll be using that very shortly in regards to if you want to use this score to get a result using the calculator, using this operations, or you want to just go to standard way and just add, subtract. The choice becomes short. But if you want to just multiply, just use the z-score. Use the list. We're going to do it that way. But anyway, I just think I have no space on the bottom because I'm afraid that there's a bright light right here where the mean's supposed to be. So what I'm going to do here is I do have guidelines here. So I'll be putting the values on top, the means and stuff on top right here, and of course corresponds to the ones at the bottom. I just can't, I'm just not able to do it because of the bright light that's right here. I do apologize for it. But anyway, let's have some fun. Let's get this stuff going. Where's my other ones at? Way over here, huh? This blue is right up, the razor right up there. I'm going to use colors black and orange, or maybe blue and orange. So here we go. So first thing first, we know we're going to have mean here, x bar, and we know that's our consistency scores. Well, up over here on this side over here, your z's on top for right now, and on the bottom your x values. So come over here, where mean is 0, where we have our mean, we should be having our 0z. That's what we're saying. So what's our mean supposed to be? Well, our mean is supposed to be, in this case, I'm going to put down orange, okay, it's supposed to be 32. And that's what over here. Actually, I'll read it to you guys. So let me read it to you guys, and we'll do it. I was quickly going to the answer. Works. But anyways, we're saying here that the weight of candy canes are bell shaped, so partially normal, or definitely normal for this one, with a mean of 32 grams. So definitely I see my mean right here. Okay? So we don't know if it's a sample property, but typically we can't get everything, so we're looking at a sample. So we're probably looking at this your x bar. Okay? And pretty much on the bottom, we're saying that, and our standard deviation happens to be 6 grams. So if we use a sample, we use a sigma. That's S. Okay? So our job is to approximate what percentage of the candy cane are candy canes weigh between 20 grams and 44 grams. So we have to better figure this out, okay, either by using the pretty much using the empirical room. But the thing is, I don't know these jumps yet. I can figure them out. So what I can do here is, well, I'm going 1 z-score to the left, so I'm increasing it by 1 standard deviation, and I could obtain that by simply adding plus 6 to it. I should do that in blue. Plus 6, and this here will result and give us pretty much 38 okay, at the first standard deviation away from to the right. If I want to do the second standard deviation from the mean, I'm simply adding another 6, which in this case should give me 44. If I'm going to get to the next third standard deviation, I'm actually keep it consistent. So one is right here. I'm going to try to keep consistent with the grid. It's right here. 1, 2. I keep the other one consistent too. Let me just fix this real quick. So plus 6 over here was going to be 36. When I added the other 6, we had the 44. And when we added the other 6, we were at 50. So I'm keeping consistent over here. I should have thought about it before. But right here is going to be my -1. Standard deviations away. Over here is going to be -2 standard deviations away, and -3 standard deviations away. So now I'm going to the left, so instead of adding, I need to subtract. So pretty much -6 over here, and that would end up giving me 26. Okay, I'll repeat the process again. -6 over here, which will give me, in this case, 20. And I'll repeat it one more time, minus 6 over here, which will give me 14. So those are you can say parameters, or the jumps that parameters go from the mean and to the 60%, to the 95%, and to the 99.7% within the mean. But anyways, we got those guys out the way. So now what we're going to do here is we're going to go ahead and see how can I do this in calculator. So once again, I showed you how to do it by hand. Okay. Not that bad. You just got to know the flow, know the process, how to do it. We're just constantly jumping by one standard deviation to standard deviation within the mean. But let's go ahead and say, okay, in that case, can I have data using z's, using the z-scores, and a formula using this? And that is yes, we can. We can use these guys, use the formula to go from z-scores to x's, and we'll get these guys naturally. And I'll show you that right now in your calculator. So, all I'm going to do is, well, come over here, and then start these guys on. So in this one, I'm going to have my z-score. So I should be building it first right here so you know what I'm talking about. So first thing first, what I'm going to do here is I'm going to go from z to x, okay, using pretty much x is equal to the z-score, sorry, that's supposed to be the mean, x bar, plus the z-score times the standard deviation. So all I'm saying here in this one, I'm going to write my z-score, starting from left to right. So we're looking at -3, -2, -1, 0, 1, and 2. And over here in this 2 is going to be my corresponding axis. So these are my z-scores right here. So I'll put z on top. These are my z's. And over here are going to be my corresponding x's. List 2. Okay. So how do we obtain these values? Well, once again, we're going to do this operation. So I'm going to have this 2 equal this expression using the appropriate values and list. So mean is supposed to be 32. So I'll write 32 right here. I'm going to add the list that contains the z's, which is this one. And I'm going to times that list by saturation, in this case, supposed to be 6. And it should naturally give us the result to be 14, 20, 6, oh, that's the wrong one, 26, 32, 36, oh, that's supposed to be 38. I'm sorry, so how can I? 38. I might say a bit word wrong. Right here, 42 goes here. 32, 38, 44, and okay. Sorry for the errors and that writing over there. But anyways, we're going to try to get those values when we do this operation. So let's come over here and do it. So over here, we're just going to put this the same pattern, so -3, -2, -1, 0, 1, 2, and 3. So I'll put all those guys in. And now I'm going to do here is, in this 2, when we have it highlighted, and press enter, so that now you say, okay, what I'm going to do to the list 2, well, I'm going to write that expression in. 32 plus the parentheses of this 1, close parentheses, times standard deviation. We're seeing the same expression. I'm going to enter it. Notice how I get the exact same results. And I do constant addition subtraction, just inputting and putting expressions in. So that's how the TI-84 works. So let's get the Inspire out real quick and see how the Inspire is working. So here's the Inspire. There we go. So turn it on. Make sure you have a new document open. I already did a new document, just so you know. And just make sure you have your list 1. Notice how I labeled list 1, so this one is labeled. Make sure yours is labeled as well. And when it comes over here, you can do the operation here, and it's not proper equals to that, but you're going to find out there's a limitation toward it in the next video, that you might do it in the calculation part on top. Okay? But let me just go ahead and put it here since we're here. So I'm going to put enter. I don't have to put enter. Oh, because I don't have this yet. So delete too quick. First label. So this too is labeled down. So now I want to enter, it says, what do you want this to equal? Well, I want the same expression. I'm looking at it being 32 plus the parentheses of this 2. And outside the parentheses, we're going to be multiplying it by 6. We put an expression into the calculator. Once again, in this portion, you have to do make sure that you're choosing variable if you're doing it through the list, and you press now you have that situated, press OK. There shouldn't have been a problem. Oh, it's this 2. Smart guy. I put this 2 in there. Let's look at this 1. So delete this 1. Okay, so hey, you can't do that. It's impossible. So this 1, and now when I enter and do the variable reference, I get the same result. So over here, we could definitely come over here and delete this now if we don't need it anymore. So I can clear it. And now when I enter, oh, come on. I messed up. Okay. Clear it. And now you could mention all these guys. And now have anything to worry about. But sometimes this might be an issue, and you have to watch out for that. So I'm going to teach you guys how to do it the other way. So do any calculator from here. And we're going to call it the same question here, but we're going to store it to list 3 this time. And you're going to see why, because in the future you might see why you have to do this. So over here, do the same thing. I'm going to do 32 plus the parentheses of this 1. And outside the parentheses, it's going to be times 6. And now when I do this, notice how when I enter, it gives me the same result. But now what you do here, instead of having to do the variable, I'm going to do variable instead of a cell. Over here, you have to worry about selecting cell or the variables. All we need to do here is go to store. So we can do storage right here. So it has to be control store. And I want to store it to this 3. Because when you do this, can't be the same list that you use today. So this 3. So now it's going to store to this 3. So now when I go to my list, notice how it's not there. We don't have it there. But once again, when I go to C and I type in list 3 and I enter, it appears. So there's 2 ways of doing things. They both take about the same amount of time. We're going to find out when you do it the other way. When you give a fraction, when you do decimals, you have to do it in the calculator. You can't do it in the list. I tried to approximate and it wasn't working for me. So that'd be the best bet for you. But that's inspired to know the limitations, know the conflict you may have when you're doing things. So now let's move on to Casio. For those of you all who have Casio in my class. Notice I already have this in here. I'm actually for the same thing. So once again, you must be in menu and you must be in statistics. So make sure you're in statistics when you do it. And then input in this 1, the same thing, and it's in order from negative to positive 3. So that's what you're supposed to have done. So if you haven't paused it, you're going to do it. And what I'm going to do here is now I'm going to list 2. Okay. And here I'm going to start writing my expression. So 32 plus the parentheses of shift 1 for list, and I'll be pressing 1 for this one, close parentheses, times it by the 6. Now enter it, it all comes in. Nice. We're good. We're golden. Okay. Each calculator is giving the same results, which is good. Just know how your calculator works. So now we got that out of the way. So now we're going to go ahead and answer the question. as you see fit. Now we have everything we need. So now what we're saying here is, well, my job is to find, well, where are these values located? Well, we just noticed that 20 is 2 standard deviations to the left of the mean, while 44 is 3 standard deviations, 2 standard deviations to the right of the mean. We're seeing them both right here. They're connected right here. So we're seeing it within 2 standard deviations of the mean. And what is it saying right here? Well, if we know for a fact that it is 2 standard deviations within the mean, we could automatically assume that, it's going to be 95%, approximately 95%. So that's what we're definitely seeing over here. We have, approximately, we can just put approximately 95%. And if you want to go the long approach and say you forgot that, well, all we're doing here is pretty much, we're in this region right here. Notice how we're in this shaded region. We're in the shaded region. So you pretty much, we're saying here, if you could have got all the sums there, and we just had the 13.59% plus the 34.13% plus the another 34.13% plus another 13.59%. You could literally have gotten 13.59 times by 2 and added 34.33, 13% times by 2. And this guy here, you put in your calculator, will end up being the same thing here. Okay? But it's good to know our shaded regions. Come on, let's shade in the regions for each one if necessary. Okay? But that one's out the way. So you might be thinking, okay, fine. How is it that I can use my calculator? Because once again, sometimes this might not be user friendly for us. And how can we get the calculator? How can we get the show the same idea, the same thing? So I'm gonna do each part I'm gonna do here. I'm gonna first show you how to do by hand, and then I'm gonna show you how to use the calculator for each one. Okay, how we're gonna get the same results. And the graphing, again, the calculator graphing one. And I'm using both of them. Okay, not good. Let me do something real quick. I do apologize for this little issue. I should have thought about this when I set it up. We'll see what happens. Good. Not too much difference. Thank you. Anyways, let's go have some fun. So come over here for the conceal. How can I do this? Well, one thing you have to understand that what we're seeing over here on this side, we're seeing empirical. We're seeing it being a normal distribution. Vowel shape is normal distribution. And in our calculator, there is something called normal distribution. So in stats, if you go to your home page, you do second shift quit. I did this shift quit to get to the main menu. You see right here distribution. Isn't that amazing? So we can hit this, and then we see here is normal right here. And since this P means point, we're not doing point, we're doing cumulative distribution. So we're going to be adding up all our cumulative distribution to do normal distribution. So we're always going to be hitting the cumulative one. But once again, it also depends on your calculator too. So when you're doing this, make sure and for the conceal, make sure a variable. So if you need to, you might see this right away, go to variable, because we're looking at variables, values. And some of you guys may not have this in your calculator. We also have the old-fashioned T84s, okay, or 86s and all those other ones, or even 83. You won't have this setup. All other calculators pretty much have this setup, and then this one with the same. This question is how do you do it? So what are we really building? What we're saying here is I want to build a normal, and sometimes it'll be okay because I'm not doing here either way. So we have normal, But what I'm going to build here is a CDF, which requires us to have a lower value. Okay? Where's the lower value for the standard deviation? Where is it located? Or X measurement. The upper X measurements. In this case, we're looking at standard deviations. Okay? So these are both X values. Okay. Next is going to be our, pretty much written here as our mu, okay, which is pretty much is our mean, and then corresponding standard deviation. Okay. If we want to do sample, same thing's happening. There's the case. Like over here, we see mu standard deviation, but this could be X bar. I'm sorry, this could be X bar and S. Same thing's happening. But that's what we're looking at. So lower X value, upper X value. So I'll put alt X and UX or upper or lower. Okay? And pretty much we're going to get this to happen. So we're looking over here and we're trying to build this. What we're trying to build? Well, we're trying to go for lower, and we said that our lower value was supposed to be 20 right here. So that means that in the lower region, I have to put in 20. That's what we put in. Upper. Well, the upper is over here at 44. So I'm putting 44 in the upper. What's my mu? Well, this is the same as my sample mean, which is supposed to be 32, and my centimeter is supposed to be 6. So I'm going to keep that consistent. So over here should be 36 and 6. So my job is to get this, and it's going to be in the same set. So when we actually copy it and paste it for so many computers, it should be reading this. And for those who are doing the T84s, the other ones, you should be writing this in your calculator, using commas and the values, and it will work. I promise you. You just gotta do it. So with that said or done, what we're gonna do here is I'm putting the information in. So lower is supposed to be the 20. So I'm put 20 right here. Well, first I'm in variable. 20 goes here, followed by 44 goes there. Standard deviation will be 6, we're good. Standard deviation will be 32, we're good. So over here, I could pretty much, you can save to this, that's pretty nice. I remember that. So you can pretty much calculate it, and there's my calculation. Okay? But I was trying to press calculate, I have heavy hands. So I'm going to exit real quick, go back, and there's something called draw. So when I'm drawing it, notice how it's doing the same type of drawing, which is pretty nice. But also notice, I'm still going to try to figure this out. I haven't figured it out yet. But how can I inputted X values? I'm trying to kind of keep it as X values. Why I don't want the standard values. I want the normal values. But anyways, we should not revert back. I'll show you guys what's the value in X. We should know already. The only thing that's different is this percentages, and we'll see that in the graphs. They're not the same percentages because we're talking about different standard deviations, so the spread is different, forcing the percentages, or I should say the densities, aka proportions, to swing down a little bit as we go further away from the mean. As a larger spread, the shrinkage, the height squashes. The lower the standard deviation increases. But that's one through, you see that through many practices, you see it happen. But anyways, that's one issue with this one. But notice how over here we're getting the same result. We're saying, oh, wait a second, if I convert this into percentages, I go 1, 2 decimal places, 1, 2, and I round. Like over here, if we round to the same, to the whole percentage, we're seeing it be 95%. So it is matching what the empirical is saying. But once again, if we're going more accurate, we should be doing into the 4 decimal places. That's here. Okay. So for ours, for the 2 decimal places, it's actually supposed to be 45, which is still approximately 95%. Okay. From this, that's more like estimation. Over here is more of approximation, because we're getting the exact values and we're approximating. Technology is going to be much more exact to get given data on a table. Yeah, we're going to use what's given to us over here. I'm just going to say, I'm not limited, I'm going to get the exact. And that's just happening. Okay. So, with this that I'm done, let me go ahead and bring out the other calculators. But I'm going to do the Inspire first because Inspire requires less work than the T84s. And the T84s are going to find out that you might need to rescale and graph. So it's very important that we know how to rescale these things. And I'll show you real quick, don't worry about that. Okay. But then again, anyways, let's try to inspire. Inspire. So menu, turn on. So for when we do inspire, when you do these type of distributions, it's always good to make a new page, so we won't get these mixed up. So over here, I'm going to do control document for new page, add page, and I'm going to have everything be under stats. Because the list and sheets is what gives us the graphs. So in this region, what I'm going to do here is I'm going to go to menu. Okay? I'm going to go to statistics, and I'm going to go to distribution, which is right there. So when I enter this one, it's going to ask what kind of distribution you want. I want the normal one, the normal with cumulative distributions. So I'm going to do the cumulative one, enter it, and ask us for the same thing. Notice over here starts with negative infinity. We're going to find out what I'm going to get it later on. We're going to see it later on. But negative infinity is going to be like a very large negative number, and possibly be a large negative number. But anyways, for now, let's fill in information. So 20 was in here. Go down to the next one. 44 was in here. Next one down, 36. Come on, Jimmy. Somehow you just always changing your numbers around. Okay, 32, my friend. Dang. I think you guys might have noticed that earlier. 32. And over here, 6. So over here, I'll show you good not graph or graph. I'm going to graph because I want to see what the shape looks like. So I'm going to graph. I'm going to have it checked off, and I'm going to go to OK. And what it does, it gives me a result, and it gives me a graph. But coming over here, that graph, it doesn't look too friendly. It's too squished up. It's like all information here that's being blocked, and over here all information is being blocked. So it's not really a good one. Especially if you're going to try to capture this image, it might not be a good one. So what we're going to do here is, how can I adjust this? Well, right here, we're just going to go to documents. Just hit document, and we're going to go to view. Oh no, wait, I said it wrong. Page layout. We're going to go to page layout, which is 5. So go to page layout, enter it, and we're going to go to select layout. So it's going to say, okay, how do you want it? Well, the one I want is a split like this, which is layout 3. I want to split top and bottom. So I'm going to have layout 3 highlighted, and I'm going to enter it. So now what to do, it splits it this way. So now we get a better idea what the graph looks like. And we know what this information is right here. We know the area, which is the density, aka proportions. Okay, and up top, I know my expression that I use, which is numeric, which is norm, CDF with the expression. And up at top, what do we see again? We see an approximation of the same thing. If you want to get more decimals, you can get more decimals by going to the settings and changing the float. The float, I think, is at 5, so it's just 5. But you can make it longer yourself. But right here we have a good idea. And the good thing right here is, look at it. It's at the same values in which I was done it. So where's the 44 from? Okay. But right here, this right here, oh, it's your scaling. That's the bad part. The scaling is based on 5, so it's not based off our standard scaling. Keep in mind, the different calculators have different scaling, so watch out for that. So right here is your 44, and it's matching. It's definitely matching relationship over here. So know your scales, okay, guys? These guys are not going to be limitations. You should know our scales, which are our jumps. Okay? We don't just blend these up from here. If you do so, it might not be good. I'm going to ask you guys write down the scales, not this scale here. I want you to write down the appropriate scales that has the parameters of the 68%, 95%, and the 99.7%. So these guys won't be appropriate. You have to rescale it appropriately yourself physically. Okay? That's what you got to do. But anyways, that's how this was working here in this calculator. I'm going to give you some answer. Pretty nice. Now for the sad one. Okay. We're going to go over here at the graphic calculator. Now this right here is very important that we talk about scaling. Oh, I should about this one now over here. Okay, to show you something. And what I want to show you is this. Notice how for my y values that my density, aka proportions that I'm looking at here, is less than 0.1. For the most part, most will be less than 0.1. Because if you look over here, we're looking at 0.3, and this is standard. This is standardized. Standard means 1 away. We're going to be looking at these are going to be 2 away, 3 away, 10 away, 15 away. So it's going to get smaller and smaller and smaller, like I said before. So when you're doing a scaling on the TI-84s, make sure you're doing something within the 0.1, okay? And with the 0.1 scaling, I'll show you what we're seeing here. But make sure you're down in the 0.1s. If you need to go upper, go ahead. But play it safe, go down because it zooms out big time if you don't do it. And you won't be seeing the shape. So that's one thing I want you guys to watch out for. But here it goes. Let's have some fun here. So the first thing I'm going to do here is I'm going to get my appropriate scaling. So like over here, I'm going to move this guy because his name is too bright over there. I do apologize. But to get the shape here, you should realize that this guy here is actually going to, of course, standard deviation. So we get the same shape. We don't want to cut it off. We want to get the nice natural shape. So I'm going to go actually one more out this way. So if I add 1 more 6, I'm actually looking at 56 over here. If I go 1 more, okay, to the plus 4. And over here, same thing's happening. It's actually going 1 more over here, okay, so we're at the negative 4. So if I minus a 6, another 6 from here, I should be at pretty much 8. So this is my z that I'll be using, and we're going to be finding our corresponding values here. Okay. So once again, once you set this up, we kind of already know what these values are supposed to be. So we know we're going to start at 8 and end it at 56, and we have our corporate scales, which is supposed to be standard deviation. I'm going to see that. I'll show it to you right now. But anyways, let me get this out of the way because it's competing. So we just look at the TI-84s. So let's get that to work. So first thing first, I'm going to do my scaling because you don't want to graph it because when you graph it first, it's going to be off, and you're going to have to re-graph it again. So scale first, in this one, scale first. So I'm going to go to my windows, and I'm going to adjust my scaling. So for my X-min, I don't want it to be 68, I want it to be 8. Because that's 4 centimeters to the right of our indicated mean. So I'm going to turn this one off and put 8 there. For the max, I don't want it to be 416. I want it to be our max, which is supposed to be 56. Okay? So I guess I get to show it here. The min that we're doing for X for the TI-84, 84 window. The min value is supposed to be the 4. It's supposed to be the z. Come on, man. It's supposed to be 8, which is the one that corresponds to the negative 4 for the z. Okay, that's what the min is supposed to be. The max for the x on the x scale, I'm gonna write. I'm sorry, min max is supposed to be 56. And this right here is going to correspond with the positive 4 standard deviations away from the mean. What is the x scale going to be? The x scale is going to be the standard deviations, because that's the scaling for the empirical. That's the scaling. So over here we're going to put 6. Okay, that's the scale we have for standard deviation. So what was this guy? This was your standard deviation. That's what it was. If you want to, sigma. Doesn't matter, it's like a 5. So we got out of the way. So once again, for my y scale that I told you before, y min we're going to figure out right now what's happening there. But for the y max, I warned you guys that when you're doing this, make sure it is below. So it's going to be at 0.1 because this guy's going to shoot down as we scale. So over here is going to be, we can put 0.1, and therefore our scale could be 0.1s. So when we look at our y scale, we could pretty much be putting right here 0.01. So my y min is going to be the opposite of the scale. So we're looking at it being this negative 0.01. I just try to keep it proportional, so when I want to convert it, it's going to work. So that is what we have to do first, before anything else. So just keep to that flow. So over here, what we're definitely seeing here is over here. So we have 8, over here will be 56, so I'm going to put 56. I have my scale 6, that's good. Over here, I have my 0.1, that's good. I have my, for max, my scale is 0.01, that's good. And over here, I have the opposite of my scale, so we're good. So make sure we have that set up. Okay. Once again, this part right here, okay, this part right here will change based off your mean and standard deviation information. But this right here, try to keep consistent. You need to readjust after later on. You guys readjust this. Okay. But that's what we're going to do. So we have that scale in. So now what I'm going to do, I'm going to go to second, and I'm going to get my distribution, which is right here, which is bars. So second bars to get my distribution. So what I'm seeing here, I'm going to do the same thing, but instead of recalculate, I'm going to go to draw. And with my draw, I'm going to look over here, and I'm going to shape the normal. So I'm going to answer the same thing. What's my lower? My lower is supposed to be 20. What's my upper? 44. What's my mean? 32. What's my standard deviation? 6. Okay, I have white here because I was doing something, or teach my students something that we don't have to do no more. But I'll go blue. I like blue. Okay, and now I could draw. And what does it do? It graphs our normal curve. And here's something very important. 0.1 is way on top. This guy is literally less than 0.1. Like I said before, before I'm the inspired, it was like in the 0.07 range. It's a little bit above 0.05. So that's one thing we have to definitely look out for. Okay? But we're definitely seeing something nice and interesting here. But what we're going to see something also important. When you look at these scaling charts, these scales right here are not really your 6s. Okay? Because look at where a center is. A center is like right here. It's not on the scale. So watch out for that. So it's just going to give this just only gives us a shape for what it should look like. What you got to do is when you graph it, you have to make it look good on your graph in your exam. Okay? It's going to be something to be output later on, but on an exam you have to make sure it's good when with the shaded regions. But over here we can see it happen. Okay, so if it's the middle, well, we're going 1, 2. It looks like it's 2 because the middle is right here. So 1, 2 is there. Same thing. 1, 2 is there. We see the within 2 standard deviations. And if you look over here, you might be hard to see, but right here, here's your area, aka density, aka probability, cumulative probability, proportions, cumulative proportions. So we get the same answer, 0.9545. So when I round it, there's my answer. Okay, so we're getting the exact same answer. Maybe I should chose a better color like black to make it see. Let me just go black because the blue might be competing too much because of the background. I do apologize for the background. Let me just do a format real quick. Because the background is what's being competed here. And the background, I'll just make it white. Okay. And I'll just go back to my graph. That's not giving information. And so we have to go back and regraph it again. But next time, I'll make sure it's in black so you can see this happen. Okay? That's my fault. I should have realized that I was competing with the background. But anyways, that's that for that problem. So let's go to the next one. Okay, now that we have all this set up for our calculators, remember each calculator has its own restrictions, its own flaws, so know your limitations and deal with it, work with it. Make it become a real good tool. Okay. So the next slide. What are we seeing? Okay. We're now seeing, okay, what if it is we change the information, and instead of it being between 20 and 44, we're saying now, what if it was between 14 grams and 38 grams? That's what we're saying now. So notice how the shading is going to change. So I'm going to erase and do the new shading, but same question, guys. I'm not changing the information, I'm only changing the condition. That's all I'm doing. I'm just changing the condition. And we're seeing what's happening. So come over here, I'm going to do some reshadings here. So what are we seeing? Well, 14. Well, if we look at top, there are more arches on top. We're seeing it be right here at the third centimeter to the left. And if you look at your 38, it's right here. 1 standard deviation to the right. So what we're actually shading in over here is this region. Ooh, too far. What's up in here? So that's the region we're looking at, right there. So notice over here, it's going all the way through, but it's not, it's stopping right here. So watch out for that. Then it goes all the way through. Know where it's stopping. So you still need the jumps. Anyways, here it is. So now if you want to do this by hand, what we're definitely seeing here is we're adding up everything that's here. Okay, we're summing up all these guys right here. These percentages. That's what we're doing. So what I'm going to do, I'm going to just put it in the calculator, but we're summing up those guys real quick. So up here, this guy, it's easier to see. Okay. So click this guy, go to my calculate. So we're consider you're always going back and forth, and also in your spot, you're always going back and forth. So over here, if I'm doing using the expression way, where we're looking here, we're looking at 2.14 plus the 13.59. Wrong. 13.59. If I'm not mistaken. Yeah, and then 34.13. So that's another 34.13. So I can just put times 2 because they're the same values. So once that's a shortcut to doing it. But anyways, now I can enter it. And I'm looking at 83.99. And that's using the Empirical. When I sum all those guys up, I'm looking at it being pretty much these guys approximately 83.99. So that's my answer. That's what's over here using the Empirical. Approximately 88.99% of the measurements we're looking at here are of the candies.